All right, diving in today, and we're looking at something pretty essential when it comes to environmental biotech.
Oh, yeah.
How do you actually get those cells you've grown, out of the liquid they're in?
Yeah.
Seems basic, but it's not.
Right.
Luckily, our sources lay out the how-to on centrifugation for us. So we're going to break down the main methods, what makes each one work, the strengths, the weaknesses.
Absolutely.
Our mission today is to understand how scientists, how industries are using this to get those cells isolated.
Yeah, this step is so critical. I mean, think of it like harvesting crops, right? You got to separate what you want from all the rest of it.
Exactly.
Centrifugation, it's like a powerful tool to basically speed up that natural settling process, right? Using force based on density.
Okay, so we're talking high-speed spinning here.
Yeah.
Let's start with batch centrifugation. What's the core idea here?
Okay, so imagine you're in a typical lab, right?
Mm-hmm.
You've got your broth full of cells in tubes. You put them in a centrifuge, and as it spins really, really fast, those heavier cells, they get pushed to the bottom. They form this solid bit. We call it a pellet.
Okay.
And then you carefully pour off the liquid. That's the supernatant.
So you're like a solid chunk at the bottom and the liquid on top.
Exactly.
And I know the machines for this, they range from those like benchtop ones you see in a basic lab to those super powerful ultra centrifuges, right?
Exactly, yeah.
All holding those tubes in different ways.
Yeah, using different rotors. Yeah.
Right, rotors.
Yeah.
And it's all about, like you said, filling those tubes, balancing them carefully.
Yeah, very careful.
Setting that spin speed in time. And then it does its thing, and then you got to carefully get the liquid out and the cells you want.
Exactly.
So this sounds pretty straightforward for smaller amounts, right? Like in research, maybe early testing stages.
Exactly. Smaller scale, pilot studies, that kind of thing.
Yeah.
It's simple. The equipment's pretty widely available, and it's adaptable for different types of samples.
It's versatile.
Yeah, versatile.
But not the best for, like, huge scale operations, right?
No, not really, because it's a batch process, one set at a time, you see.
Yeah.
That limits how much you can process. It takes more labor, especially for large volumes. And it's generally not what you see in like big industrial bioprocessing.
Okay, so when we go big, we're talking continuous centrifugation.
Right.
So how's that different?
Well, instead of batches, you've got this constant flow of broth going into the system.
Okay.
Separation happens without stopping, and you get a continuous output of both the solids and the liquid.
Wow, like an assembly line.
Exactly. Very efficient.
Our sources highlight disc stack centrifuges as a common type.
Yeah, for getting cells, those are popular.
What makes these so special?
The design, it's really clever.
Okay.
They have this stack of cone-shaped discs inside. And as the broth flows in, the denser solids get pushed outwards towards the edge of those discs, while the liquid moves towards the center. Think of it like a crowded highway. The heavier, slower trucks, they get pushed to the outer lanes.
Right.
And then the collected solids, they're discharged either intermittently or continuously.
That's a neat analogy, the highway.
And, it's actually a similar principle used in the dairy industry.
Oh, really?
Yeah, to separate cream from milk.
Fascinating.
Yeah.
All right, so tubular bowl centrifuges, those sound pretty different.
They are, yeah. These spin at super high speeds, and they have this long cylindrical rotor.
Okay.
The forces they generate are really strong, good at separating even tiny particles.
Right.
But the solids build up inside, and you have to remove them periodically.
Right, makes sense.
Yeah.
And lastly, decanter centrifuges. These sound like the heavy-duty ones.
You got it.
For the really thick stuff.
Exactly, yeah.
Slurry, that kind of thing.
Yeah, they use a horizontal bowl, and inside there's this screw conveyor.
Oh, interesting.
It's perfect for slurries with lots of solid material like you see in wastewater treatment.
Oh.
They help to remove sludge, and the screw continuously pushes those settled solids out.
Very efficient.
Yeah.
So with these continuous systems, there's a lot to manage, right? To keep them running smoothly.
Oh, absolutely.
What are some of the key things, the operational parameters you have to pay attention to?
Well, the feed flow rate's a big one.
Okay.
You got to control it carefully, too fast, and you won't get good separation too slow, and you're not processing enough.
You're bottlenecking.
Exactly.
Okay.
Then you got the rotor speed,
which
basically determines the G-force, how many times the force of gravity is pushing down.
Wow.
And that's chosen based on how big and dense your cells are.
Makes sense.
Temperature matters, too, because it affects the viscosity of the broth, how thick it is.
Right.
In disc stack centrifuges, you've also got back pressure, which helps control how concentrated those discharged solids are.
Interesting.
And the solid discharge rate, that prevents buildup inside.
So a lot of fine-tuning involved.
So really.
And this makes sense for processing those large volumes, right?
Yeah.
Like bacteria, yeast, fungi,
Uh-huh.
even getting rid of cell debris.
Exactly, yeah.
The advantages are clear, right?
Yeah.
The high-speed, continuous operation.
Absolutely. Very efficient.
But I imagine there are trade-offs.
Yeah, for sure. The initial cost of these machines can be high,
Okay.
and they use a good amount of energy to run,
Right.
and there's a risk of damaging the cells
Oh, right.
because of the strong forces involved.
From the spinning.
Yeah. And how well they work can also depend on the size of the particles and the viscosity of the broth.
So like we said, it's a choice based on many factors.
Yeah, absolutely.
Our sources made that very clear.
Yeah.
The scale you're working at, the type of cells, where your product is,
Mhm.
what the next step in your process
Yeah,
is.
right.
And of course, the budget.
Always got to consider the budget.
Yeah, that's always a factor.
It's about finding that balance, for your specific needs.
This has been a really interesting look into centrifugation.
Yeah, it has.
It's amazing how this basic scientific principle gets adapted for such important stuff in biotech.
It really is, and it makes you wonder, with biotech advancing so fast,
Mm-hmm.
what totally new methods might we see for separating cells in the future?
Yeah,
Maybe even going beyond this idea of spinning things at high speed.
right. Beyond centrifugation.
Yeah, what innovative approaches are out there,
What's next?
Yeah, it's a fascinating question to think about.
A lot to ponder.
A lot to ponder.
Thanks for joining us on this deep dive.
My pleasure.